Alright, good morning, functions. This is what I would like you to do. I would like you to put this warm-up in your notes. This was something that students struggled with in class, so I would like you to take this down, and I'd like you to try to answer it on your own. Okay, so I'm going to go through this one at a time. Again, when we're finding f minus g, you want to find f minus g of x first. So here's what I did. I put my f function right here in parentheses, and then I did subtraction of my g function. I went ahead and put the 1s in front of the parentheses to remind me that I need to distribute either a 1 or a negative 1 so that I get the right terms and I don't mess up my signs. Then I ended up with 2x cubed plus 2x plus 4, because 1 times anything is itself. Then I got negative 1 times 2x, which is negative 2x, and negative 1 times negative 1 is a positive 1. Then I combine my like terms. I only had 2x cubed, so I put that there. Positive 2x minus 2x is a 0x, so I didn't need to write it. And then 4 plus 1 is 5. Now I can go ahead, and now that I know what f minus g is, I can go ahead and start putting in my new input. So that's what I did here. So I have everywhere I see an x in this function, I'm going to replace it with my new input. So I have 2 times 3w cubed plus 5. Well, don't forget that 3w cubed actually means 3w times 3w times 3w. So that gives me a 27w cubed. Because 3 times 3 is 9, times 3 is 27, and then w times w times w is w cubed. Then I have the 2 out front from the original function, which is right here, plus 5. I went ahead and evaluated that, so 2 times 27w cubed is 54w cubed plus 5. So then I wrote my final answer right here. Then, to find f times g of x, I went ahead and I put my first function here, and I did it in parentheses. Whenever I put in an input, I always have it in parentheses. And then I put my g function here. And I did them in different colors so you could see what I was doing. Well, this means this times this, so then I had to put it in my area model. So again, because I do it the same way every time, I put the first function vertical, the second function horizontal, and I put it right here. I went ahead. So 2x cubed times 2x is 4x to the fourth. 2x cubed times negative 1 is negative 2x to the third. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. And 2x times 4 is 8x and negative 4. One of the reasons why I like that box is I can see what my like terms are right away, and I can just write my final answer. So I went ahead and did that. So I have f times g of x is equal to 4x to the fourth, because there was only one of those, negative 2x cubed, there was only one of those, plus 4x squared. Again, I didn't have anything to combine it with. Now I have 8x and negative 2x, so I combined those, and I got a positive 6x and then a negative 4. And that's my final answer. All right. And then the last one, f of g of negative 2w. So again, the first thing I do is I find f over g of x. So I know what function I'm working with. So I put my f function on the top and my g function on the bottom. And then I went ahead and I put once I had that, there was nothing left for me to simplify. Normally, you would be able to factor something, but I didn't need to factor anything. So I went ahead and did that, and then I plugged everything in. So then I have 2 times negative 2w cubed plus 2 times negative 2w plus 4 all over 2 times negative 2w minus 1. Again, don't forget that negative 2w cubed is actually negative 2w times negative 2w times negative 2w. So I went ahead and evaluated that because order of operations tells us I need to do my exponents first, then I can deal with everything else. So I went ahead and dealt with my exponent. So negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 is a negative 8. So I got negative 8, and then w times w times w, is that 3? Yeah, is w cubed. So now I have 2 times negative 8w cubed, and then I went ahead and did 2 times negative 2w, negative 4w plus 4, and then I did the denominator. 2 times negative 2w is negative 4w minus 1. And then I went ahead and distributed that 2 and got my final answer because I had nothing. So negative 16w cubed is 2 times negative 8w cubed is negative 16w cubed minus 4w plus 4 over negative 4w minus 1. So my final answer is right here. There was nothing that I could factor out a 4 here, but it wouldn't really help me because I can't factor anything out here. So that is my final answer. And it looks like my face is in your way, so I'm going to move this up. So there's the final answer. All right. Now I would like you all to please get this down in your notes. We're going to do some composites with numeric inputs. So go ahead and hit pause and put this in your notes. Okay, so what I did first is I always, when I'm doing composites, I always evaluate the function closest to the input. So for this particular problem, it's the g function. So I went ahead and found g of 3. So g of 3 is equal to, well, my g function is 2 over x, and anywhere I see an x, I replace it with a 3 right here. So that's what I did. And there's nothing left to simplify, so I take that new output, and that becomes my input for my f function. So now I have f of 2/3 is equal to, again, everywhere I see an x, I'm going to replace it with my new input. So 3 times, because 3x, so 3 times 2/3 plus 2. Well, whenever I have a whole number times a fraction, I just need to remember that 3 as a fraction is just 3 over 1. So then I can do fraction multiplication, which is typically the easiest. It's something that we always try to turn it into anyway, because top times top equals top, and bottom times bottom equals bottom. So 3 times 2 is 6, and 1 times 3 is 3, and I get 6 over 3, which can reduce down or simplify down to 2. So then I end up with 2 plus 2, and that equals 4. So then my final answer is f of g of 3 is equal to 4. And then I'm going to do the same thing right here. So g of f of 3. So now I'm going to take care of the f function first. So I'm going to find f of 3. So f of 3, everywhere I see an x, I replace it with a 3. So 3 times 3 plus 2. Well, 3 times 3 is 9, plus 2 is equal to 11. Now I take that new input, because that's my output for this one. It's going to be my new input for this one, and I went ahead and stick it out the outside function, which is my g function, which is g. One second. There's nothing left to simplify, so 2 over 11. So my final answer for g of f of 3 is 2 over 11. Go ahead and get this table in your notes and get these in your notes. Okay, so now we're going to be finding a composite from a table. Hopefully you already have this in your notes, but something I want to talk about is that we've not seen a table like this. This is why we have functions, and this is why we name functions different things. It's so we can condense things. So I only have one table, but I have 2 functions represented. Just kind of like that graph we did last week where we had one graph with 2 different functions on it. We just named them differently. So again, all of my inputs are going to be my x values. They're right up here. So whenever I'm looking for an input, I'm going to be looking up here, no matter what function I'm talking about. Then I have my f function is the second row. Those are all going to be the answers or the outputs for the different inputs for the f function. And then the third row is the g function. So I kind of realized that students were struggling with this, so I broke it up like this. So if this is hard for you to look at, take this table, and hopefully you do have this table in your notes because you're going to need to know how to do this. But I went ahead and broke it up into 2 different tables because we've seen that before, and sometimes that's a little bit easier. So I went ahead and put all my inputs because they're the same, right? If you notice, if you look at both of these functions, I have my inputs of -3, -2, -1, 0, 1, 2, 3. Then depending on the function, my outputs change. So when the input is -3 in the f function, my answer is 11. But when my input is -3 on my g function, my answer is -8. So that's something that we need to look at. So the first thing I had you do was that we were going to find f of g of 1. So the first thing we always do is we find the input for the one closest to the input. Find the answer for the one closest to the input, which is g. So g of 1. Well, if I go up here, my input is 1. I go to the third row because that's my g function, and I come down here, and my answer is 0. Now that's my new input, and I'm going to put it inside the f function. So I go back up here, I go to 0, My f function is in the second row, so I go down, and my answer is 5. So then the answer is of f of g of 1 is 5. I do the same thing for here. Find f of 2. I'm sorry, g of f of 2. So first, I go up, and my input is 2 in the f function. So I go to my inputs, 2. I go down. Oh, it's 1. I plug that in right there. I go back up to 1. I go down to my g function, and my answer is 0. And then the same thing for g of 1, which isn't something we've seen yet. A function of its, like a composition function of itself. So if we do that, again, I evaluate g of 1. So g of 1, I go up to my 1. G is in the third row. It is 0. And then I put that in for this, and I go back to the top. 0 is my input. Go back down to the g function, and I get 1. So then I end up with 1. All right, go ahead and get this in your notes and hit pause. Okay, so now we're going to do composites with equations. So again, the first thing I always do is I evaluate the function closest to the input, and that is my f function. So I find f of x. Well, this is easy. F of x equals x squared plus 3. So then that's what I put. I'm done. I've evaluated it. I've found it. I'm done. Now I take that entire output, and I'm going to plug it into my g function right here. And then I'm just going to simplify. So my g function is 1 minus 4x, so I have 1 minus 4, my new input. And then I just get 1 minus 4x squared minus 12. And then that's going to equal negative 4x squared minus 11 once I combine all my like terms. So my answer for this one, for g of f of x, is negative 4x squared minus 11. Now to find the domain is a little bit different. We kind of have to think back about our transformations and our parent graphs. My parent graph for this one is going to be y equals x squared, which is just a parabola right here. And because of that, I know that I can figure out my domain for this one. Because all I'm worried about are what are the values that I can put in, or is there a value of x that will break this function? Well, when I go look at this, that means it's going to be negative, so it's going to be upside down, and it's going to end down and start down, because again, even degree, 2. So then I know it's going to go forever negative this way and forever positive that way. So then my domain is just going to be negative infinity to positive infinity because it's a parabola, and there are no values of x that I can plug in that won't work. Then we do the last one. So now we're going to find f of g of x. So again, I evaluate g of x first because it's closest to the input, which is 1 minus 4x. I take the entirety of that output and I plug it into my f function right here. Now I'm going to find f of 1 minus 4 of x, 4x. So I do that. I plug it in right here. Well, my f function is x squared plus 3, so I put 1 minus 4x squared plus 3, and then I need to remember that 1 minus 4x squared is equal to 1 minus 4x times 1 minus 4x. And it's something I have to remember, and because those are binomials, I need to put it in a box. So I did that there, which I particularly like, because then I can combine my like terms without having to write it twice. So then I get 16x squared minus 8x plus 1, and then I still have that plus 3 to evaluate, which gives me a final answer of positive 16x squared minus 8x, because 1 plus 3 is 4, so plus 4. So f of g of x is equal to this, 16x squared minus 8x plus 4. Again, the domain. I know that my parent function is a parabola again. So then I know that there are no values of x that I can't plug in. Everything's going to work. So from negative infinity to positive infinity. All right, so the next slide is this one. Please get this down in your notes, and we'll go over it together. Hit pause, please. Okay, so I evaluate this the exact same way. I found my f function, I plugged it into my g function, and I get 3 over 4x plus 3. So my final answer of g of f of x is 3 over 4x plus 3. There's nothing left for me to simplify. I have this in parentheses, which reminds me I can't break it up. But to find the domain, it is going to be negative infinity to positive infinity, but there is a value of x that will break it. And that is that my denominator can never equal 0. And since it can never equal 0, friends don't let friends divide by 0, then I need to set this denominator not equal to 0 and figure out what that value is. So that is what I did here. Please get this in your notes. Hit pause before my video runs out. All right, and I did the same thing here. Again, I have to set my denominator not equal